Alright, my name is Eshan, and today we're going to do Fall 2024 Exam 2. So for this first question, it's a method of undetermined coefficients question, where it's telling us to find the correct form of the particular solution yp of this equation. So first thing we're going to do is we're going to always start on the left side. We're going to use the characteristic equation method. So here we have y triple prime, so that would be r cubed minus 4r. And we're going to set that equal to 0, and we're going to find the roots. So this is from pre-calc, and from here we can find the roots as r equals 0 and plus or minus 2. Plus and minus 2. And from there we can build our characteristic equation. So yc, which is c1, and imagine if this was c1 e to the 0t, but e to the 0 is 1, so that corresponds to the 0 root. c1 plus c2 e to the 2t, that corresponds with this one, plus c3 e to the negative 2t, which corresponds with the third root. Sorry, I'm kind of sick right now. So now what we're going to do is we're going to guess the form of the right side. We're going to guess the form of yp. So ypg we'll call it. And what that means is we're going to look at the right side. So we're going to look at the form of the right side, and then we're going to guess the form of yp. So if we have t, we know that it's going to be at plus b, because t is to the 1 degree. If this was t squared, we would use at squared plus bt plus c. But since it's just t, we're going to do at plus b. So that's for the first term. Now for the second term is 3 cosine of t. And so whenever we run into cosine or sine, our guess for the form is going to include both sine and cosine, and you should always have the same term inside the cosine or sine as it is in the original form. So in this case, we're going to have c cosine of t plus d sine of t. And then for the last term, we have e to the negative 2t. So we're just going to have plus big E to the negative 2t. My roommate's in the bathroom, so that's what you're hearing. I'm going to keep this in the video. Alright, so now we have our guess for now we have our guess for yp, and now what we're going to do is we're going to check for duplicates between yp, our guess for yp, and our yc. So nothing here. Oh, actually we do. We have one duplicate right here. So I'm just going to highlight that right here. And let's see, do we have any other duplicates? Yep, right here. So I hope you understand what I mean when I say duplicates. We have a constant. This is a constant. C1's a constant. B's a constant, and we have a constant times e to the negative 2t, same as here. So how are we gonna deal with our duplicates? So we're just gonna multiply it by the amount of duplicates there are. So in this case, there's one duplicate for each term. I mean, so in this case, there's one duplicate here. So we're going to multiply that entire term by t. And remember, at is included in this term. And our cosine and sine remain the same because there's no duplicates. And then we're going to multiply this one as well by t. And so now we check our duplicates again. And as you can see, between this and this, and as you can see, our former b constant is now multiplied by t. Alright, he's done in the bathroom. I'm still keeping this in, by the way. So we have bt here, which is not a duplicate of c1 because c1 is just a constant. And here we have et e to the negative 2t. And here we have c3 e to the negative 2t. So I hope that makes sense. So that's not a duplicate anymore. We removed the duplication. So now we're just going to write this out fully. At squared, the way that the answer choices are built. And that's my fridge that just came on. This is a very noisy video. Sorry about that. So, there we go. So that should be in our answer choices somewhere. So we know it's not that. We know it's not that. Let's see. It looks like e. At squared plus bt plus c cosine t plus d sine t plus et e to the negative 2t. Oh, that's horrible. God damn. Alright, so for number 2, it's asking us to select a differential equation which is equivalent to a first order system. And so we're going to start by saying that we're just going to say that x1 is x. So x equals x1. And from there, we can just take the derivative over and over again and make it equivalent to x2 prime, x3 prime, etc. So now from this statement over here, x1 prime equals x2, we can apply that to this, and we see that now I can write it like this. So x2 equals x1 prime, which is just x prime. And so we can do the same thing next. Which is just x3. Because from here, we know that x2 prime is just x3. And so now we're going to do x triple prime. We can skip all the middle stuff because we just know that that's x3 prime. Right? And so now what we're going to do is we're going to use that statement. We're just going to rewrite this statement, but in terms of x and x prime. So we have x3 prime, which is like we just said, x triple prime. We have 2t x, and x1 is just x, right? Like the first line, minus t squared x prime, because x2 is just x prime, right? Minus x3 is just x double prime, as we said, and then minus 3e to the t. And we're just going to bring all the x terms to one side. And we're going to leave the negative 3e to the t on that side. And so from that we know that x plus t squared minus, yep, that's the answer. Alright, so for number 3, we have, it says, find a general solution of the system of differential equations, and it gives us a system right here. And so first thing we're going to do, like always, is we're going to find the determinant. So we have our a minus lambda I. Which is going to be this 4 minus lambda, 2 minus lambda, negative 1, 1. And from there, you're going to do your cross multiplying. So that times that minus that times that times that minus that times that. And from there, you get from there you get that you can factor because it's a perfect square. And now you have lambda equals 3 with a multiplicity of 2. So now we can solve for our eigenvector like this. So we're going to use a minus 3i, our lambda is 3, times v, or say v1 equals 0. So what that looks like is this. And so this is our a right here. So we're going to do a minus 3i, and then identity matrix. So we're going to do 4 minus 3, which is 1, negative 1, 1, and then 2 minus 3, which is negative 1. And we can call this a1, b1, set it equal to 0. And from there we can solve easily, because we have a1 minus b1 equals 0. This is just a system of equations. We have a1 equals b1, which means we can let, for the eigenvector, we can just let them both be 1. And so now when you have when you have eigenvalues with multiplicities, with multiple multiplicities, like 2 in this case, you use you can do this. So you can use your old, you can set it equal, you have to set it equal to your old eigenvector. So we can call our second one v2, and then instead of setting it equal to 0, you just set it equal to 1, 1. So we have the same thing here. And then, sorry, my roommate's also sick. Set it equal to 1, 1 instead of 0, 0. And again, it's just another system. a2 minus b2 equals 1. And then from there, you get a2 equals 1 plus b2. And from here, you can just let b2 equal 0, which makes a2 equal 1. Which means you get a eigenvector, a linearly independent eigenvector of 1, 0. And so from there you can build, now you have your v1 and v2, which means you can now build your equation, your general solution. So there are repeated eigenvalues of 3, which means we can build a general solution. So what we're going to do, we're going to have x of t equals c1, and we'll just say v1 e to the 3t, because the eigenvalue is 3, r3. Then we're going to have c2, and then since it's repeated, we're going to do v1 times t plus v2 e to the 3t. So based on that, we can say c1 1, 1 e to the 3t plus c2 t plus 1, 0 e to the 3t. And then we can just combine them, plus c2 t plus 1 t e to the 3t. So here, hopefully you saw that all I did was, this was v1 is 1, 1, and then t is just t, so you just multiply it through, so you get tt. So we were just looking for this in our answer. Oh, and there it is. It's b, I think, plus c2. Yep. Alright, so this question is about slope fields. It says, identify the direction field of the following system of differential equations. And so as soon as you see something like this, you're going to try and find the eigenvalues. So for this one, we have, find the determinant of negative 2 minus lambda to that. Then you do your cross multiplying, so that times that minus that times that. And with that you get That's a square. From there, you get, and you can solve this in many different ways, including quadratic formula, but I'm just going to do it like this. And now you know that you have, so clearly you have a complex eigenvalue, which automatically means that your slope field is going to be some kind of spiral, either spiral sink or spiral source. But the way that you know whether it's a source or a sink is by looking at the real part of the complex eigenvalue. So the real part of this one is a negative, which means it's a sink. If it was a source, it would be positive. Excuse me. The way I remember that is if it's negative, like, sink, like bad. Negative, sink, bad. And then positive, source, like you're adding stuff, you're getting things from something. So plus. I don't know, man, just memorize it. So from there, you just look at our slope fields, and you can immediately say that it's not that, or that, or that, because those are not spirals. And since we know it's a spiral sink because it's negative, you just look at which one is a sink. That one looks like a wormhole or something, so we're going to choose that one. And that is the correct one. Next one, number 5, it says use the method of undetermined coefficients to find a particular solution, xp of t, of the non-homogeneous system, and it gives us a non-homogeneous system. All that means is generally you have x prime equals ax like this without this part, the f of t part. But when you have a f of t part, it becomes non-homogeneous. Given that xc equals c1 negative 1 to e to the negative t plus c2 1 to e to the 3t, that's our general solution of our homogeneous system. So if this thing wasn't there, if it was just this part, then our solution would look like that. But now we have to find the particular part of the solution. So the way we're going to start with this one is we're going to guess our particular solution based on the form. So we have xpg of t, g as in guess, and so we have a constant constants times e to the t, which means our guess is going to be something like a1 or a b to the e to the t. And from that, we're going to take the derivative once. Well, first we're going to check that if there's any duplications. That's important. Any duplications between this and between this. And at first glance, you would think there is, but make sure to pay attention to what's in the exponent of the t. And if it doesn't match, then you're good. So there's no e to the t's here, so it means there's no duplications. So now we're going to take the derivative of our xp. It's no longer a guess because we checked for duplications. Xp prime, and derivative of this is derivative of this is just itself, right? And then based on that, we're basically going to plug these two things into here. So we have xp of t, we'll say xp equals 141, and then we have xp here again, plus our f of t, our non-homogeneous part. And so this should have a prime on it. So now we're just going to substitute the appropriate equations in. So our xp prime just happens to be the same as our xp in this case, but and ab e to the t plus 2 negative 1 e to the t. And from there, you just you do some matrix multiplication between these two, and then it just becomes a system, and you can just solve from there. And we can also divide out all the e to the t's, because every term has it. So we have a, b, and then we get a, b here. And I'll just add the third matrix in here as well. It should actually be a plus b plus 2. If you don't remember matrix multiplication, I don't know, go back to linear algebra. I didn't mean to sound that mean, but go see 265 videos or something, because I don't remember matrix multiplication either. Minus 1. So a plus b plus 2, and then 4a minus, or 4a plus b minus 1 on the bottom. And again, this is just a system of equations, so we can just take out the equations on the side like this and solve them. Excuse me, holy shit. So minus a on both sides, we get b equals negative 2. I'm not going to go over this too much because this is basic algebra. And from here, we can just sub in negative 2 into here and solve. And we get that a is negative 1 over 4. Which means that now we go back up here, and we know that our xp of t is negative 1/4. Hold on, is that right? So we put in the negative 2 here, here, add plus 2 both sides, so this becomes 4a minus 1 equals 0. We add 1 to this side, divide by 4. So this should be actually positive. Sorry about that. Like that. And that should be the right answer right here. Alright, so for number 6, it says find the matrix exponential e to the at for the matrix A, and it gives us an A matrix. So for this one, you just need to know one of the formulas. So it says, so our formula is going to be e, and then in this case, well, first of all, let me just break this this matrix up into this. You kind of just, when you see matrix exponential questions, you kind of just have to do this. You have to look for like an identity matrix. So here we have, as you can see, an identity matrix times 3. And then our second one is just going to be 0, 0, and then the one not identity matrix. And so this is just 3i, and this was called b. And so the formula you should remember is e to the at equals e to the 3i plus b times t. So what that'll look like, so e to the 3i, so this equals e to the 3i t times e to the 3b t. Sorry, not 3b. Holy shit. B, like that. And then you're going to split it up, so e to the 3it is just like this. You're just distributing into the matrix, into the identity matrix, times, and then, so one thing I forgot to go over, so when you have B, you have to square whatever B matrix you have until it becomes 0, until you hit the nilpotent matrix. When I took this class, I had no idea what that meant either. It's kind of a funny word though. So for this one, you just have to square it once, and you get 0. So what that literally means is you have your b like this, and you square it once, and it's all zeros. In the scope of this class, most of them will just be 2, maybe 3. You just have to square them until it becomes nilpotent, like that. And that 2 means something because you only had to square it once until it became nilpotent, which means that now your e to the bt is just going to be I plus bt. So you see here the t of degree 1 because you only had to square it once. If you had to square it multiple times, it would look something like I plus bt squared plus bt plus b, or some constant. But in this case, it's just I plus bt, and I think for the scope of this class, most of them will be like this. So e to the bt is going to be I plus bt, which is just, your identity matrix, plus bt, which is literally just negative 6t, and then zeros everywhere else. And then you're just going to add those together. So you have 1 minus 6t. Actually, no, you're multiplying it, so. Oh, this is not an identity matrix. That's my bad. You're not multiplying it, ignore me. 0 minus negative 6t is negative 6t. And now you have your e to the bt. So back up here, and then after just some basic matrix multiplication, you'll get e to the 3t, negative 6e, negative 6t, e to the 3t, e to the 3t, 0. And that should be the answer right here. So for number 7, it's just a simple Laplace problem. You can use your sheet, obviously, so we're going to simplify it. This hint basically tells us that we have to simplify our f of t. So we can do that like this. And then you take your Laplace of f of t. Actually, before I do that, let me actually use the hint. 1 plus 2 cosine of t plus, and then it tells us what cosine squared is. And then we're just going to break it up so it's easier. So we can take this 1/2 and add it to this constant 1. So we get 3/2 plus 2 cosine of t plus 1/2 cosine of 2t. And now we can take our Laplace transform and you just go term by term, and like you have a Laplace sheet. So for 1, it's 1 over s, which means it's going to be 3 over 2s. For cosine, it's s over s squared plus 1. For cosine t, so we're going to have 2s over s squared plus 1. And then for cosine of 2t, it's the same thing. This should really be 1 squared, but 1 squared is just 1. And then for cosine of 2t, we're going to have our 1/2 coefficient in front. And then the Laplace of cosine of 2t is just s over s squared plus 2 squared, which is 4. So finally, we're going to have 3 over 2s plus 2s over s squared plus 1 plus, and then you're going to have s here, 2 times, this should be 2. Like that. And I believe our answer should be B, which checks out. Alright, so for number 8, we're going to use, it says, use a variation of parameters to find a particular solution to, and then it gives us an equation. And it gives us our two solutions, y1 and y2, so it makes our life much easier. So we're going to start with the Wronskian. So our Wronskian, the formula for our Wronskian is going to be y1, y2, and then their derivatives. And our Wronskian will be the determinant of this 2 by 2. So for us, it's going to be our y1 is given as x squared, and then x cubed for y2, and then we're going to take the derivatives, and we're going to get the determinant. And we get x to the fourth. And so this x to the fourth is going to be important. So now we're going to find our u1 and u2. So the final thing we need is obviously the particular solution. And the equation of particular solution is u1 y1 plus u2 y2. And for u1, the formula is going to be negative y2, and this is important to remember, times your constant, your f of t. In this case, your f of t is this 7, or whatever the non-homogeneous part is on the right side. So 7 over your Wronskian, and you take the integral. And for u2, it's very similar. You have y1 times your f of t over Wronskian. And so for us, it's going to be negative, and then our y2 is x to the third times 7 over x to the fourth. Uh-oh. What the hell? Okay. My GoodNotes is tweaking. So from there, you're going to have that, and we can just bring this here. And now we know that our u1 is going to be negative 7 ln x. For u2, we're going to have x squared times 7 over Wronskian, which means that we're going to have 7 times 1 over x squared dx, which means our u2 is going to be negative 7 over x. So for now, we can build our yp based on that. So u1 times y1, our y1 is x squared, plus u2, which is negative 7 over x, times y2, which is x cubed. And now we can just simplify this with some canceling, and we can factor it, and we end up getting that, I believe. That should be the correct answer. Alright, so this question is just one of your average IVP problems. So first thing we're going to do is find eigenvalues, as always. So we have our negative 1 minus lambda. And it's going to be straight line because it's determinant. We get and from there, simplify a little bit, and like that, which we can simplify to x plus 4 times x minus 2 equals 0. Oh, I don't know why I switched to x. And then, which from there we can get our two lambdas as negative 4 and 2. So now we find our eigenvectors. So our lambda 1 is going to be, we'll just say 2. And so you're going to have your lambda minus, or you're going to have your negative 1 minus lambda, and your negative 1 minus lambda. So negative 1 minus 2 is negative 3. A1, B1 equals 0. And based on that, you can just write an equation like this, and you can set both equal to 1, and so our V1 is going to be 1, 1. For our next eigenvector, we're going to have two eigenvectors, linearly independent, because we have two eigenvalues. So our lambda 2 is negative 4. Negative 4 minus negative 1 is negative 3, or excuse me, 3. Wait, negative 1 minus negative 4, sorry, it's 3. A2, B2, so that equal to 0 again. And from here we basically get A2 plus B2 equals 0, which means our eigenvector will be 1, negative 1. We're basically just choosing values that make this equation true. And from there you can build your general solution. So we have x of t c1 e to the 2t, and that's because this eigenvector is associated with the eigenvalue of 2 plus c2 1 negative 1 of e to the negative 4t, again for the same reason. And now to find, now you built our general solution. So to build the actual solution, that's why we're given initial values. So x of 0 equals 1, 5. So you're just going to plug in x of 0. And here, e to the 0 is just going to be 1. So all you're left with is c1, 1, 1. Same thing here. And that equals 1, 5, like it's given to us. And now it's just a system of equations. So we have c1 plus c2 equals 1, and c1 minus c2 equals 5. And I won't spend much time on solving this simple system of equations, because you should already know that. So based on that, we know that c1 is going to be 3, and you can just use substitution or whatever for this. 3 and negative 2 are constants. And so now you just plug them in back into your general solution. So our c1 is 3, 1, 1, e to the 2t, minus 2, 1, negative 1, of e to the negative 4t. And obviously, I'm sure your teacher or your grader will accept all kinds of answers, as long as it's right. So obviously the form will change for everyone based on how much they simplify, and etc. Alright, so for this last one, it's an undamped mass spring system, and it gives us an equation, and it asks us, there's two-parted, and it asks us about resonance, and then it asks us to find a particular solution of the system. So first of all, I'm just going to say that the form for a mass spring system is going to look like this. So mx double prime plus cx prime plus kx equals some function. And so in this case, as you can see, c is going to be 0, which is why our system is undamped, because the c is the damping constant, and it's 0, which means that m is 1 and k is 1. So from there, you can do part A pretty quickly, because you know that your resonance is going to be root k over m, which in this case is 1, which means that, and you experience resonance when the right side of your when the right side of your term is equal to the left side of your term. So the system will experience resonance when omega equals omega naught, and which is 1 in this case. So remember this 1, basically. For B, this is when we're actually going to use that. So it tells us to basically plug in this, tells us to plug in that value and solve the system. So we're going to plug in that value and then rewrite our system. So we have x double prime plus x equals 2 cosine, and then I'm going to plug in omega as 1, so we just have 2 cosine t. And from here it's pretty simple, just the method of undetermined coefficients. So we're going to do characteristic equation and then set it equal to 0. From here we can get that it's a complex eigenvalue with a real part of 0, so it's plus or minus I. From there we can build our xc, which is c1 cosine of 1t, because it depends on the coefficient of I. If it was plus or minus 2i, then you would do c1 cosine of 2t, but it's just 1, so c1 cosine of t plus c2 sine of t. And now you're going to guess your particular solution, which means that it looks like my roommate's back in the bathroom. So you're going to have your particular solution guess, and for that you're going to look at this part. So 2 cosine t, and like I said on the first question, whenever you see sine or cosine, your form is going to be a cosine t plus b sine t, or 2t or 3t, depending on whatever it is. Here we just have t. So we're going to have a cosine of t plus b sine of t. And this is where we check for duplicates. So are there any duplicates between this and this? And as you can see, they're both duplicates. So what do? We just multiply by t, or multiply by t until there's no duplicates. We only have to do it once here, so we're just going to do at cosine of t plus bt sine of t. And as you can see, no more duplicates between these two. And then from there, you're going to take the up to the double prime, because there's a double prime here, and we're just going to plug it in, right? So x prime, oh, he's done with the bathroom. I'm still keeping that in as well. You have xp of, wow, he really slammed the door. So we have our first derivative of x particular is going to be just product rule over and over again. So a cosine of t minus at sine of t plus b sine of t plus bt cosine of t, and x double prime is going to be even larger than that. So we have x, or I'm going to start here. We have negative a sine t minus a sine t minus a t cosine t plus b cosine t plus b cosine t plus bt sine t. And well, I guess it wasn't that long. And I guess we could simplify that all into combined like terms. We get minus 2a sine t plus 2b sine t, or cosine t, minus at cosine t minus bt cosine or bt sine t excuse me. And from there we can just now do undetermined coefficients and compare with our f of t. So this is our f of t. And as you can see, we can basically throw out all of these. We don't have to gather these b's, a's and b's, because they're multiplied by t, and we don't have a term like that, so it's going to be 0 anyway. So we can just throw out these two. Or excuse me, I did that totally wrong. Let's do it again. So you have your x double primes and your x, and so now you're going to plug it back into here. So you have negative 2a sine t. I'm just going to copy this down. I'm lazy. That, and then we have plus x right here. So for x, we're just going to use that. So plus at cosine t plus bt sine t, and all that equals f of t, which is 2 cosine of t. And so now you're just going to gather your coefficients. So we have 2 here, and then all the terms that don't multiply by t before the sine or cosine will be equivalent to that. So again, here's where you can throw out these terms, because they're all multiplied by t, so it would be 0 anyway. So now you can just gather that negative 2a, and then you also have to gather by cosine and sine. So I'm going to gather all the cosine coefficients together and all the sine coefficients together. So for a cosine, we just have 2b. This is a plus, by the way. 2b equals 2, because we have our 2b, 2. And then for the other one, we have negative 2a equals 0, because there's no sine terms on this side. And so that's your system, and obviously b is going to be 1 and a is going to be 0. And now you have your coefficients. So you can take this and then go all the way back up to here. So a is 0, so that term is just going to disappear. B is 1, so our answer is going to be t sine t, because all we're doing is we're plugging in this b over here. As you can see, there's no a is 0, so this just disappears. So you just have this second term. So yeah, that's the answer.